Oh, thank you, Mohammed. Right. Is audio working okay?
Yeah, yeah, everything is
Great.
okay.
Share my screen here. And I think we are good. Right. So I'm going to talk to you about a tool that I've been developing and working on for a few years now called Tranquilizer. And the tagline I like to say is put your Python functions to rest. And we'll explore a bit deeper about what this little pun means. So my agenda here is to talk at a high level about what it means to productionalize an ML or AI model. And you may have heard this word. It gets used a lot these days, or deploy or operationalize. And I'm not going to try to go through every one of those buzzwords, but I'm going to give you an overview of what that means and how people do that. And they generally do that by creating what's called a REST API, a little web server microservice way of inputting data and receiving a prediction. And then we'll wrap up with an example of how we can use Tranquilizer to go directly from our Jupyter notebooks to a serving REST API. And you can take that then to any number of cloud services. And so let's start with this productionize. And I think I've changed my spelling here. You can say productionize or productionalize. It's fairly open how people sort of interpret this. But in a general sense, I want to be able to create a prediction service. I've got my Jupyter notebook that has my model code and everything's all wrapped up there. And it can be challenging for other people to utilize that, especially people who are not seasoned data scientists. And there are some people who really don't like Jupyter notebooks for a number of reasons, some of which are more valid than others. And to be able to create a prediction service means that I can use the power of my machine learning model in an application, maybe a phone app or some other way of getting this information. And the real goal is to be able to enable non-experts, non-data scientists, to be able to interact with my model. And in general, the word people use is somewhat more often as deploy. I've got a machine learning model. I want to deploy it, make it available as a service. And you'll find dozens of articles all over the web about how people are doing this. And in general, they're commonly sort of aligning around using a microservice approach, a little web server with a particular sort of structure to the way that it accepts and sends information called the REST API. And so here's a little graphic to kind of put this all together. And in reality, everybody has already been using something really close to a REST API. Every website you visit has most likely got a back-end service to feed the data into the thing that you see on the front. So the client here is my desktop computer, and I'm sending requests back and forth to an API. And so just like a website that you put in your URL bar in your browser, we're going to talk about programmatically accessing data from the web, where we're going to have the same sort of structure with a domain name. Here's some website.com, some path, some way of identifying, the kind of information I want and how it's laid out. And in the end, this endpoint. You might think of the endpoint as a function, and that's going to be a very useful abstraction for us a little bit later. And in reality, microservices are now the building block of modern web scale applications. You can think of something like GitHub that I'm sure many of you have used. The GitHub front end, what you see on the website, is all powered by requests to some REST API to retrieve information about a user, about a repository, say about issues. And this is a very powerful abstraction that allows developers to separate their application into multiple smaller components, say the interface, this backend service, and now adding in these ML AI prediction models or recommendation engines. And all of this can be written in different languages, controlled by different teams, And all they need to make sure they do is align on how these HTTP requests are being made, what information comes in, what it looks like coming out. And it makes it very easy to scale the components that need to scale. If the database needs to be a little bit bigger, or if you need more CPU and RAM for the prediction engine, you can scale those components individually. And you could even swap them out. And that's something else that you may have heard about in the news with, say, your news feeds on some social media, is that you get in little experiments. The companies are going to test out a different prediction model, and they can do that very rapidly with microservices and REST APIs. So let's see a quick example and something that maybe you're not so aware of. I'm going to go and work with a REST API right here from my browser. I'm going to look at the GitHub API. And so I'm going to visit api.github.com/users and my name, Albert DeFusco. And instead of seeing a nice web page with graphics and buttons, I'm just looking at the raw data. And this is coming back to me in a JSON format, the most common way of sharing information on the web. And this is the nuts and bolts of working with a REST API. It's all the same kind of things that happen on the web, just without all the JavaScript and the nice graphics. Going to my terminal here, I can work with this REST API in a programmatic way, say using the curl, make a request to the site and get back this information. And I can use it programmatically, for example, in Python. And I do that with the request package. And here I'm doing a couple of things at once. I'm saving all of that information here in a response object. The response is telling me I didn't have any error codes. And I can convert that into Python objects like dictionaries and lists by parsing the JSON. And so I can extract individual pieces. And these are just sort of the basic ways that we can interact with these REST APIs, again, served by any number of mechanisms. We're going to talk about how we can build these REST APIs in Python. And before we get too deep in there, we're going to go talk a little bit more about why this REST API is so useful and important. And I see it as a way of piggybacking on mature technologies that have been around since the dawn of the internet to enable these very new cutting-edge machine learning services and capabilities. We can piggyback on technology that already knows how to do authentication and authorization, that already knows how to think about scaling up these services, and then becomes broadly compatible. I was using this thing with my web browser. I was using it with my Unix command line and with Python. People know how to work with HTTP requests, and it becomes very easy for them to work with your machine learning model. And so REST here stands for Representational State Transfer, and it's a specification for sending and receiving information over the web, over HTTP protocol. And there are a number of common commands that we use to retrieve and send information. In the examples I was showing up till now, we were using the GET request, which is your way to retrieve information. And that's what your web browser already does. Every time you visit a HTTP website, you're performing a GET request and receiving back information. Your browser is receiving HTML and JavaScript, and it uses that to render the website. When we start doing programmatic REST API calls, we'll be able to post and update and put new information into the service. So you might use the post to create some new record, or the put an update to update that later on and be able to delete from it. And this is all sort of been built up on a sort of database-like model. So it all looks like selects and inserts and updates and deletes. And we see that the post request command is the one most commonly used for ML and AI models. Now let's see another example of this post before we continue on here. And I'm going to again use Python. And what I want to do is send data to GitHub. So I've got here the URL for the issues on my GitHub repository for Tranquilizer, and we'll just open this up right here as well. And what I want to do is programmatically create a new issue. And so I'm going to send it some bit of information. I'm sending it a new title and a body, right? So I'm going to send this new bit of information. So the data here is now a JSON encoded string, and I'm going to use the requests library with that URL. I'm not showing you my headers because that has my secret token authentication information in there. And to do this in Python, there are a number of tools and frameworks. The leading tools are things like Flask and Tornado and Django, and emerging tool called Fast API that I really like and find very interesting. But the problem for us as junior data scientists or even seasoned data scientists is that this requires a lot of code. It requires sometimes a lot of knowledge that a more software engineer background may have, people with a history of web programming in Python. And so it can take a lot of effort, and it feels overwhelming to try to learn how to do this, especially if you spend a lot of your time in Jupyter Notebooks, because these tools don't natively support Jupyter Notebooks. But every time you go out to the web and say, how do I productionalize my model? The first thing they say is, we're going to need to make a REST API. And sometimes they'll show you all of the code it might take in some of these other tools to get there. Now, along the way, you're probably aware that several cloud vendors have developed these end-to-end machine learning platforms that can take you from data exploration to a deployed model being used in production. Things like SageMaker or Seldon, IBM, and many others provide a service that can help you get all the way to a REST API. And those are really powerful and very valuable products, but not everybody uses them. And the tool that I'm going to talk about today, Tranquilizer, is somewhere in the middle. It's not going to be as much code as it takes to use Flask or Tornado, but we're also not tied to a cloud vendor. We're going to be able to create our own REST APIs in Python and be able to take them wherever we need to. And we're also not pinned to machine learning and AI. We'll be able to write REST APIs for anything that we can do in Python. And so really the dream is to change this graphic a little bit and to say, I want to develop my API using Jupyter and be able to have it interact with the client just like any other API that we can interact with out on the web today. So it would be great if I could take this little function. This is a function that's converting Fahrenheit to Celsius, and be able to serve it as a REST API. What we're looking at the right here is a standard documentation style presentation of a REST API that's called Swagger. And we can see here that there's an indication of a HTTP GET with an endpoint called toCelsius. That's the same function name as in my notebook here. And it takes an input, a number, the value in Fahrenheit. And with this Swagger view that we can open up in our web browser, we can practice with a REST API. And many of the REST APIs out there on the web also have this Swagger documentation that you can visit. And it's something that is pretty common. So this is our dream. We want to go from notebook to served REST API with as little work as possible. And so Tranquilizer lets us do that in as little as one line of code. and with a simple command line function to run. And as I said, it's not just for ML and AI models. So here's my function again, 2 Celsius. There's a couple of things going on here that you may not be really familiar with. Firstly, I'm using what's called type hints. I'm telling the person reading the source code that Fahrenheit really should be a float, even though Python won't enforce that. Python doesn't care whether I use a float or a string to call this function, but by using type hints, I'm informing the person reading the code that you should really use a float here. This is what I intended to. I intend it to return a float back, but it could as easily return an integer, unlikely with the division. But these type hints are not currently used by the standard Python interpreter to sort of error or block your code from running if some of these things don't match. But they're going to be really helpful in generating our documentation with Tranquilizer. And so to enable Tranquilizer for a function, I just add the tranquilize decorator. And the key skill here is to be able to write good functions. Type hints go a long way, and they're very powerful. And as we'll see in the example a little later on, if you write good doc strings, we'll be able to add even more documentation to our REST APIs. And you can get access to the Tranquilizer package here at the source at GitHub. It is an open source BSD licensed package where you can install it with pip or conda. And so we want to be able to create these REST APIs from any Python function. We can have as many Python functions as we wish within a Jupyter notebook or within a Python script file. Tranquilizer will automatically create this Swagger documentation for you, with a few caveats on the way that you write these functions. It works really well when the inputs can be JSON serialized. And we don't need to belabor that point too much right here in this talk, but things like strings, numbers, lists, and dictionaries are the most commonly used arguments in your function. Tranquilizer goes a little further and tries to help you out with something more sophisticated, like having datetime variables. You can pass NumPy arrays, you can create REST APIs that receive image files or text and binary files. Something that, again, is a bit harder to do with Flask and Tornado, but still possible. And finally, we'll demonstrate that Tranquilizer is easily integrated with Docker so that you can take it to a larger service. You can use things like Nginx for reverse proxies, SSL encryption, and all sorts of other web technologies. And it becomes very easy to integrate this into larger ecosystems. And so to install Tranquilizer, you can get it from pip or conda. It's a good point to also make sure you add the nv-convert package if you're using Tranquilizer with a Jupyter notebook so that it knows how to read that notebook correctly. The second step is to decorate whatever functions you need to in your Python code. And then finally, to run the Tranquilizer server. Here we're using the command line tool Tranquilizer that works on Linux and Windows and Mac. We give it the notebook or script file, and it will run the server here on our desktop. And at the end, we'll show an example using Docker. So let's take a look at how we put together a REST API from a machine learning model using Tranquilizer. And you'll see here at the bottom is a link to the project that I've prepared for this talk. Let's go take a look at that. So here in this GitHub repo, I have two notebooks, one to train the model, one that we'll use to serve the prediction functions. I've got all the data that I need here and the packages that need to be installed in an environment.yml file compatible with Conda. So I'm using Python 3.8. Because I'm going to be developing in a Jupyter notebook, I'm using the notebook package. I'm reading data with matplotlib. or with pandas doing some plotting, and I'm going to create a machine learning model with scikit-learn and serve it with Tranquilizer. So I've downloaded the repository to my desktop. I've created the Conda environment, and now I can run Jupyter Notebook and get started. And so we'll start with the train notebook. And here's my task. My job is to predict the total number of bike rides for the local Pittsburgh bike share system for any given day. And things I know today are the forecasted maximum temperature, the month, and two Boolean flags: is today a weekend or a holiday? And so I've prepared some training data to support making a model that accepts these inputs. And I've gathered training data for several years worth of bike rides within the city. So for every day over the last several years, I know the maximum temperature as recorded. I have the month, whether that day was a holiday or a weekend, and I've gathered the total number of bike share rides. The bike data is all public information in here, and I think I'll upload the data processing notebooks as well to this repo a little bit later after this talk. So I've got all of my data here, and to sort of indicate that I may be able to make a reasonable model, I can see that there is some correlation between the maximum temperature and the number of rides. Certainly, it's not very popular to go take a ride when it's below freezing. But there is some nonlinear trend here. I feel like I could probably make a reasonable enough machine learning model. So I'll begin by splitting my data into train and test, and making sure that I stratify across something like weekend, or you can stratify across month, to make sure that you put enough data and you don't sort of miss something important between training and testing. And I'm going to go ahead and use a gradient boosting model here to build my regressor, because I have this nonlinear trend. A simple logistic regression wouldn't work as well here. And I need to do a little bit of processing on this raw data. And I'm going to do that, use the column transformer, so that I can put together a number of different pre-processing tools all at once to operate on the input data. I need to do a one-hot encoding on this month column, because that's a string, and our machine learning models can't really deal with strings natively. I need to scale the maximum temperature between 0 and 1, and I'll use the min-max scaler. And then I'm just going to pass through the two Boolean columns, weekend and holiday. And I've chosen a couple of hyperparameter values here for the estimators and the validation fraction and the tolerance here on my gradient boosting regressor. And I put all of this together in a pipeline. And the reason why I'm using a pipeline here is very important, because I want to be able to accurately reproduce all of these data processing steps on new data when I create my prediction engine. My prediction engine is only going to receive the maximum daily temperature as a number between, say, 0 and 120 or so. Well, probably like -10 or so. And I'm going to have to let the pipeline scale it for me as it's making a new prediction. And that's pretty easy to do by putting everything in a scikit-learn pipeline. So we'll fit the model, and we'll see if it's pretty good. So we get a decent balance between the train and the test score. Maybe it could be improved a little bit. So I've got my model ready. And to think about the next steps in productionalizing it, it's important to think about saving the model or persisting the model. I need to save the model as it is right now, because I don't want to go and retrain it. This was a pretty quick model, but in reality, models can take a long time to train, and just to use them in a REST API, I shouldn't have to retrain them. I should use them as is. So I'm going to create a pickle file. And in the next step, when we create our prediction engine, they're going to read that back in. So moving over to the next notebook, let's form the prediction functionality, and we'll start to serve that as a REST API. And so to do this, because I'm using the model pickle file, I don't even have to import scikit-learn. I need to have it installed, but I use joblib to load the model into memory. Then I can use that anywhere I need to inspect the model or to create predictions. And I've put together a couple of functions here. The first function is going to give me a way to report on the hyperparameters used to train the model. I'm going to prepare that and serve that as a GET request in Tranquilizer. The function here is called params, so I'll look for a params endpoint later on. And this is going to return for me a dictionary. So by decorating a function here in the notebook with Tranquilizer, it doesn't change how the function works. I can still use the function without any modification or notice that anything's different in my notebook. But when I go and serve the Tranquilizer model, because this function has been decorated, Tranquilizer will go and pick that out from all the other code in this notebook and make sure that that gets served. And now on to the prediction function. As we know, the prediction function needs to accept maximum temperature as a float, month as a string, weekend and holidays as Boolean values. And so I type hinted all of those things because that's going to add that type hint to my documentation. It's also going to validate so that when a user is trying to send a request to the REST API and they send a string instead of a float for max temp, they'll get an error telling them that that was the wrong thing to do. And now something new with this function is I'm using my doc string here to provide extra documentation. A doc string in Python has two main parts: a short description in one line, a blank line, and then a longer description of the function. Here I'm using what's called Sphinx style parameter identification. I'm identifying that max temp is a parameter input to the function, and I'm giving it a little bit of a description how to use it. All of this will be picked up by Tranquilizer and put into that online documentation. And so finally, I put all of my values together in a data frame, just like my original training data, and I can predict with it. It's going to do all of the pre-processing steps automatically for me because it's in that scikit-learn pipeline. And again, my Python function hasn't changed. It's still available, and I can still run it as is. So see, today is April, and it's pretty warm today, but it's not a weekend or a holiday, and I predict around 284 bike rides today. So I've got my notebook put together, and I'm going to serve this notebook as a whole REST API with those two endpoints. Now, normally you might do that in the command line, but I'm already here in the notebook, and I'm going to go and run the Tranquilizer right here from my notebook. And again, this works on Windows, Mac, and Linux. And that's going to start up the server, and I'll allow the connections. And right here, I can click on the link and visit the documentation and practice with my REST API. Again, I see I've got my two endpoints, a params and a predict. And the good thing about Tranquilizer is it lets me practice, or the Swagger lets me practice with the endpoint. I can execute this endpoint, and I get back those values. It also gives me the curl command, as I showed earlier on the command line. Let's take a look at the prediction function as well. Notice here that that first line description from the doc string came right in this documentation here. And then because I added each of those parameters in the doc string, they also get added in here as a description. We see that the data type matches number and string and Boolean. Let's try this again. So 85.0, it's April, not a weekend, not a holiday. And again, I get 559. And that's all it takes to get into using REST APIs with Python, especially with Tranquilizer. I've imported the Tranquilize decorator, and I go and decorate any function I need. And I'm not changing anything about my functions. Their functions are still valid Python, and they would still work the same way even without the tranquilizer decorator. So back to the slides. Let's talk about some best practices as we wrap up here. It's good to write fast functions. Users like it when their web sites load quickly. People like it when the REST APIs return data quickly. It's important to not mess with anything that you've got loaded into memory. And we call this changing the state of something like a global variable. You don't want to set some dictionary or some list and append to it, because then every time I run my REST API endpoint, it might give me a different value back, and that can be a bad thing. And this is generally a good practice for creating REST APIs. And something specific to Tranquilizer is you want to avoid unnecessary cells. And that's the reason why I put my predict function in a different notebook from my train, because I don't want to rerun all the training steps. I just want to use the model that I created, that I saved as a pickle file. And so it's a good idea in Tranquilizer to avoid loading data, or at least avoid setting up cells that take a long time to run, because all of them are executed when Tranquilizer starts. And then it may take a long time for it to warm up and be ready. And then you can have a large memory footprint for this model and this REST API. And something really important for TensorFlow is to make sure you load the model outside of those functions, because if you have the model load inside the function, it can easily consume all the memory. And that's just a standard best practice for TensorFlow, and a good idea for scikit-learn as well. And to finalize this, now that we've learned how to create a REST API, you can now take that with you. You can take that into a container and build a Docker image that contains your notebook and your model files. That Docker image can then be brought to a cloud hosting service, things like AWS and Azure and Google Cloud, I'm sure all have ways of running a Docker image. They can then be put together with more sophisticated things like reverse proxies and other things like load balancers to make a really robust REST API. And to learn more about this thing, the best thing you can do is to identify that anything you can do in Flask, you can do with Tranquilizer. So if you were to just go find something on the web, how do I run Flask on AWS? You could think about just replacing all of that Flask code with Tranquilizer, replacing the sort of run app.py with the Tranquilizer command. And you should be able to make use of any of that information out there on the web. And to give you a little preview here, there's a Docker file in the repository, and it is a very short Docker file to base it on a mini conda base image. We copy in this project. It's going to have my notebooks, my data, my environment.yaml, which is then utilized in the run to create and install all the packages. And then finally, I'm using conda run, so I don't have to worry about activating my my environment to run the Tranquilizer command over the predict function. And again, that's going to serve it here on port 8080, which is somewhat common, I see, when people use Docker. And so that concludes my sort of overview of REST APIs, why they've become really important in machine learning and AI, and how Tranquilizer helps get you started on that, and is a great way to take your Jupyter notebooks and to start to build REST APIs, to productionalize them, to deploy them. And so thank you for your attention today. And if you want to get in touch with me, you can find me on LinkedIn.